A simple clay jar could rewrite the entire story of human invention. This is the mystery of the Baghdad battery. These unassuming artifacts, found in an ancient Iraqi village, suggest a power we believe was discovered millennia later. By the end of this journey, you will see the timeline of progress not as a straight line, but as a map full of intriguing blank spaces. We will examine if these objects truly generated electricity and for what forgotten purpose they might have been used. How much of our past remains hidden in plain sight? The year was 1936, and the dust of Mesopotamia held more than just the remnants of empires. German archaeologist Wilhelm Koenig was overseeing a dig near the ancient capital of Ctesiphon, a site layered with centuries of history. His team was likely expecting pottery, coins, the usual fragments of daily life. What they unearthed, however, defied easy categorization. Among the finds were a number of small, unglazed clay jars, each roughly the size of a person's fist. At first glance, they seemed ordinary, perhaps just another type of storage container from the Parthian era, a period spanning from around 250 BCE to 224 CE. But their contents told a different story entirely. Inside each jar, Koenig found a carefully rolled sheet of copper, formed into a cylinder. Suspended in the center of this copper tube was an iron rod. The entire assembly was sealed at the top with a thick plug of asphalt, a naturally occurring tar-like substance, which held both the iron rod and the cylinder firmly in place, while also insulating them from each other. The iron rod showed clear signs of acidic corrosion. This was not a random collection of scrap metal. The construction was too deliberate, too specific. It looked for all the world like a primitive but intelligently designed apparatus. Koenig, who had a background in art history and museum work, was deeply puzzled. These objects did not fit any known category of artifact from the period. They were not religious idols, not tools for weaving or farming, not decorative items. They were something else entirely. After careful study, he arrived at a hypothesis so radical it was almost heretical. In a paper published later, he suggested these jars might have been ancient galvanic cells. In simpler terms, he proposed they were batteries. His theory was based on the basic principles of electrochemistry. If the jar was filled with an acidic or alkaline liquid, like vinegar or grape juice, the electrolyte would react with the two different metals. The iron rod would act as one electrode, the copper cylinder as the other, and a small electrical voltage would be generated between them. The asphalt plug served the critical function of keeping the electrodes apart, preventing a short circuit, while allowing the iron rod to be accessed from above. This was not a complex machine, but it was a functional one. The immediate questions were overwhelming. If these were batteries, what on earth were they powering? How did the ancient artisans discover this principle? And why does no historical text from the era mention such a technology? The discovery sent a quiet tremor through the world of archaeology, presenting a puzzle that was both elegantly simple and profoundly disruptive. The design is deceptively simple, a quiet masterclass in primitive engineering. To truly grasp why this object unsettles historians, we need to look at its blueprint. Start with the jar itself, a hand-formed terracotta pot about the height of a coffee mug. It is unglazed, porous, and utterly ordinary. Inside, the ancient artisan placed a carefully rolled sheet of copper, forming a cylinder that lines the inner wall. Suspended perfectly in the center of that copper tube is a solid iron rod. These two metals never touch, and that is the first critical clue. They are separated by the air inside the cylinder, and more importantly, by the jar's final, ingenious component, the seal. The top is plugged with a thick layer of bitumen, a tar-like asphalt that occurs naturally in the region. This substance was poured or pressed in while hot, hardening to create an airtight, watertight lid. It grips the iron rod tightly, holding it in place while also completely insulating it from the copper cylinder surrounding it. Every part has a purpose. The clay jar is the sturdy, inert container. The copper and iron are the two dissimilar metals required for a chemical reaction. The bitumen is the insulator that prevents a short circuit. Now imagine filling that jar with a common liquid from the ancient world, something acidic like vinegar from wine, or even something as simple as citrus juice. This liquid, called an electrolyte, would soak into the porous clay and surround the metals. A chemical reaction would begin immediately. The acidic solution would start to corrode the iron rod, causing electrons to flow from the iron through the electrolyte to the copper cylinder. If you were to connect a wire or even a metal object between the iron rod sticking out of the bitumen and the copper cylinder, you would complete a circuit. A small but measurable electric current, likely around 1 volt, would flow. This is not a theory of advanced physics, it is basic electrochemistry. The jar is in function, a primitive but fully operational galvanic cell, a battery. Its design is not a random accident of corrosion. It is a specific arrangement of materials that produces a specific effect. This precise mirroring of a fundamental scientific principle, found in an artifact 2,000 years old, is what transforms a simple clay pot into one of history's most compelling mysteries. The most compelling explanation is also the most practical. What if these batteries were simply tools, used not for magic or medicine, but for craft? The leading hypothesis suggests they were employed for electroplating, the art of depositing a thin layer of a precious metal, like gold or silver, onto a more common surface. We know the civilizations of Mesopotamia were master gilders. They created breathtaking statues and jewelry adorned with gold leaf, often using a dangerous method involving mercury. This process, while effective, was toxic and difficult to control. The discovery of a cleaner, more precise method would have been a revolutionary secret for any ancient workshop. Imagine a skilled artisan in a dusty studio. They have a small copper amulet, perhaps a pendant meant to honor a deity. They want it to shimmer with the sun's own light. They fill one of the clay jars with an electrolyte, maybe vinegar or fermented fruit juice. They connect a wire from the copper cylinder of the jar to the copper amulet. Then they dip another wire from the iron rod into a solution containing dissolved gold particles. When the circuit is completed, the gentle current from the battery would slowly draw those gold particles onto the surface of the amulet, bonding them at a molecular level. The result is not a foil that can peel or tarnish, but a permanent, radiant coating of gold. This is not just speculation. In the 1940s, an American researcher named Willard Gray built exact replicas of the Baghdad jars. He filled them with grape juice as an electrolyte and confirmed they could produce just under 1 volt of electricity. He then successfully used that small current to electroplate a silver object with a layer of gold. The experiment proved the concept was not only possible but remarkably straightforward. This theory transforms the artifacts from mystical objects into the working tools of a guild. It suggests a hidden chapter in the history of technology, where the spark of electricity was not a force to be studied, but a quiet, utilitarian trick known to a select few metalworkers. They may have used it to gild the fingertips of a temple statue, or to make a king's ceremonial ring gleam with an otherworldly finish, imparting a literal aura of divinity to the objects of power and faith. The question then becomes not if they could do it, but what beautiful, gilded treasures, now lost to time, were once brought to life by this ancient current. Yet another possibility exists, one that moves the mystery from the artisan's workshop into the quiet chambers of ancient healing. we have records scattered across early civilizations that reveal a surprising awareness of bioelectricity long before the term was ever coined. Ancient Greek and Egyptian medical texts describe the use of a peculiar creature, the torpedo ray. This fish possesses specialized organs that can deliver a powerful electric shock. Physicians of the era would have patients stand in shallow water where these rays lived, or even place the live fish directly on the body to treat conditions like chronic pain or headaches. The numbing jolt was not fully understood, but its effects were undeniable and recorded. This demonstrates a foundational, experiential knowledge that electricity, harnessed from nature, could influence the human body. Could the Baghdad batteries represent an attempt to replicate and control this phenomenon? Imagine a low, consistent current, perhaps just under 1 volt, applied to the temples or a sore joint in a quiet temple dedicated to Asclepius, the Greek god of medicine. The gentle tingling or mild muscular twitching would have felt utterly foreign, otherworldly. In a time when illness was often attributed to spiritual imbalance or divine disfavor, such a sensation could easily be interpreted as a direct intervention from the gods, a magical touch that drove out pain or induced a state of altered consciousness for ritual purposes. This perspective is supported by some modern parallels. Today, transcutaneous electrical nerve stimulation, or TENS units, use low-voltage electrical currents to provide pain relief for millions. The principle is not to overpower the body, but to gently interfere with pain signals. The voltage range of a replicated Baghdad battery falls strikingly close to the settings used on some of these contemporary therapeutic devices. This hypothesis transforms the clay jars from tools of craft into instruments of proto-science and faith. They become devices for a healer priest, blending early empirical observation with spiritual belief in a unified quest for wellness. The current they produced may have been seen not as a physical force, but as a conduit for divine energy, a way to bridge the gap between the material and the mystical in the timeless human struggle against suffering. But perhaps the most captivating possibility lies not in the hands of a craftsman or a healer, but within the silent, incense-filled halls of a temple. In the ancient Near East, the boundary between the physical world and the realm of the gods was porous. Priests were not just spiritual leaders, they were keepers of knowledge, masters of spectacle who wielded what we would call technology to manifest the divine. A gentle electrical current, utterly inexplicable to the average person, would have been the ultimate tool for such a purpose. Imagine a darkened chamber where initiates gather. At its center stands an idol, perhaps plated with a thin layer of gold by those very same batteries. A priest, unseen, completes a simple circuit. A low hum, barely audible, begins to emanate from the statue. To a worshipper's trembling hand, its metal surface now carries a faint, mysterious vibration, a palpable energy that feels alive. That subtle tingling sensation would not be interpreted as chemistry. It would be experienced as a direct touch from the deity, a physical sign of a spiritual presence. The psychological impact is profound, transforming faith from a concept into a sensory, undeniable reality. The applications could grow even more elaborate. We know from historical accounts that ancient temples often employed hidden tubes and chambers for priests to speak through, making statues seem to utter prophecies. Now introduce a small electrical charge. A thin metal diaphragm behind the statue's mouth, connected to a battery, could be made to vibrate with the hidden priest's voice, amplifying the sound or adding an unearthly, resonant quality to the oracle's pronouncements. The effect would be terrifying and magnificent, a perfect fusion of acoustic engineering and electrochemical trickery designed to inspire absolute awe. This theory recasts the Baghdad batteries as sacred objects, the carefully guarded instruments of a priestly class. Their purpose was not to power a device but to power belief itself. They were a technology of wonder, used to demonstrate the priest's unique connection to cosmic forces, to make the intangible tangible and to solidify their authority by literally bringing the gods into the room. In this light, the jars are not failed experiments or abandoned tools. They are the very heart of a ritual designed to bridge the gap between the earthly and the divine through a spark of controlled mystery. Of course, not every historian is willing to follow that current into the unknown. For every voice proposing an ancient spark of electricity, another offers a far more grounded and perhaps more probable explanation. The skeptical perspective is compelling in its simplicity, arguing that we have been overcomplicating a common artifact. These jars, they suggest, were not batteries at all, but something much more ordinary: storage containers for sacred texts. In this view, the iron rod was simply a convenient handle. A precious scroll made of delicate parchment or papyrus would have been carefully rolled and placed inside the protective copper cylinder. The thick asphalt plug served a purely practical purpose, sealing the container against the damp, preserving the fragile writings inside from the ravages of time and climate. To retrieve the scroll, a priest or scribe would simply grasp the iron rod and lift the entire inner assembly out of the clay jar. This interpretation fits neatly within the archaeological record, where the preservation of written knowledge was a paramount concern, and specialized containers for scrolls were well known. Scholars who favor this theory point out a critical absence in the evidence. No wires, no metal connectors, no electroplated objects have ever been conclusively found in direct association with these specific jars. If they were part of an ancient electrical workshop or temple apparatus, where is the rest of the toolkit? The resemblance to a galvanic cell, they argue, is just a fascinating accident of design, a coincidence that speaks more to our modern fascination with technology than to the intentions of the ancient artisans. This skepticism is not a dismissal of the mystery, but a necessary anchor for genuine historical inquiry. It reminds us that the most extraordinary claims require the most robust evidence, and that sometimes a jar is just a jar. Yet, even within this pragmatic view, a question lingers. If these were merely scroll cases, why choose such a specific and complex combination of materials? Why use iron and copper together, metals known to interact, when a simple wooden dowel and a ceramic liner would have served the same protective purpose without the risk of corrosive damage to the precious text inside? The very design that makes them plausible as batteries also makes them curiously over-engineered as simple storage. This tension between the mundane and the miraculous is where the true puzzle resides, forcing us to look closer, not just at the object, but at the silent context that surrounds it. The true weight of these jars is found in the world that created them. To judge whether an ancient people could have harnessed electricity, we must first step into the vibrant, bustling crossroads of their civilization. The artifacts are most often placed within the Parthian Empire, a realm that thrived from around 250 years before the Common Era to 224 years after, or its mighty successor, the Sasanian Empire, which endured until the mid-7th century. This was not a dark age of stagnation, but a golden era of connection. These empires sat at the very heart of the Silk Road, a sprawling network of trade routes linking the Mediterranean with China. Caravans did not just carry silk and spices, they carried ideas, stories, and entire schools of thought. In the great cities, one could hear debates between Greek philosophers, Persian astronomers, and Indian mathematicians. This was a cosmopolitan melting pot where innovation was not just possible, it was inevitable. The Parthians and Sasanians were master builders, constructing vast archways and complex irrigation systems that defied their terrain. Their metalworkers were legendary, producing swords of legendary strength and jewelry of breathtaking intricacy, often using advanced techniques like fine soldering and gilding. They absorbed knowledge from every culture they touched, blending Greek geometry with Persian engineering and Indian medicine into a unique body of practical science. Within this context, the idea of electrochemical experimentation shifts from a shocking anomaly to a plausible, even expected discovery. Imagine a curious artisan in a workshop filled with metals and acids, substances used daily for etching, cleaning, or dyeing. Through simple trial and error, a process repeated for centuries in the pursuit of better alloys and brighter finishes, someone might have noticed a strange tingling sensation when two different metals were connected in a vinegar bath. They would not have called it voltage or current, but they would have recognized it as a novel and potentially useful effect, a hidden property of the materials they knew so intimately. This suggests these civilizations operated with a form of proto-engineering, a hands-on understanding of natural forces gained through relentless experimentation. The Baghdad battery, then, may not represent a lone genius, but the tangible product of a culture steeped in craftsmanship and open to the secrets hidden within the physical world. It is a relic from a time when science was not a separate discipline, but an inseparable part of art, trade, and the daily pursuit of mastery. Yet these jars of potential power are not solitary whispers from the past. They join a quiet chorus of ancient anomalies, objects that stubbornly refuse to fit neatly into our timeline of progress. Consider the Antikythera mechanism, a complex bronze gear system recovered from a 2,000-year-old shipwreck. Far from a simple ornament, it functioned as an intricate astronomical calculator, predicting planetary positions and eclipses with a sophistication unmatched for over a millennium. Or ponder the mystery of Damascus steel, the legendary blades wielded by crusaders, whose wavy pattern and unparalleled strength were lost for centuries. A metallurgical secret modern science has only recently begun to fully replicate. Even in the carved stone reliefs of the Egyptian temple at Dendera, some see not just symbolic serpents, but striking representations of what could be interpreted as giant light bulbs, complete with filaments and insulated cables. And ancient descriptions of sacred objects, like the Ark of the Covenant, with its detailed specifications for gold plating and warnings against direct touch, have led some scholars to theorize about primitive electrical capacitors, devices storing a dangerous charge. What connects these disparate artifacts across continents and cultures? They each represent a peak of specialized knowledge, a technological insight that appears, shines brightly for a time, and then vanishes from the common record, often for ages. This pattern suggests that human innovation does not march in a single, unbroken line upward. Instead, it may be more like a flickering flame, sometimes burning brilliantly in one isolated workshop or temple school, only to be snuffed out by war, social collapse, or the simple loss of a master artisan who took the secret to their resting place. Viewing the Baghdad battery alongside these other puzzles changes the question entirely. We are no longer asking if one group of people stumbled upon electricity. We are asking if multiple cultures, in their own ways, occasionally brushed against deeper principles of the natural world, principles they harnessed not as a science, but as a craft or a sacred art. These artifacts become fragments of a much larger, incomplete mosaic, hinting that our ancestors' understanding of their world may have been far more nuanced and far more ingenious than our history books often convey. The proof, as they say, is in the replication. To move beyond speculation, modern researchers have turned to experimental archaeology, a field dedicated to rebuilding the past with one's own hands. By constructing faithful copies of the clay jars, using only materials and techniques available 2 millennia ago, they have sought to answer the most basic question: can this thing actually work? The results are consistently clear and surprisingly straightforward. When filled with a simple electrolyte like vinegar, grape juice, or lemon juice, the replicas reliably generate a small but measurable electric current, typically between 0.5 volt and 1.5 volts. That is enough power to produce a faint but distinct tingling sensation on the tongue, a tangible proof of concept that would have been impossible for an ancient experimenter to ignore. A single cell, of course, is not particularly powerful, but the principles of electricity were not unknown, even if not formally understood. If an artisan discovered that one jar created a slight tingle, what would happen if they connected 2 or 3 or 10? By linking several cells together in a series, a concept known as a battery bank today, the voltage would add up. While no archaeological evidence, like wires or metal connectors, has been found to confirm this practice, the theoretical possibility is striking. A bank of 10 such cells could produce over 10 volts, enough to deliver a noticeable shock, power a small light, or significantly accelerate an electroplating process. These modern experiments do something remarkable. They bridge the immense gap between a static artifact in a museum case and the living, breathing curiosity of a human mind. They show us what an ancient craftsperson might have witnessed in their workshop: the slow, mysterious darkening of a solution, the subtle accumulation of a new metal on a surface, or that peculiar, vibrating buzz felt through a fingertip. They prove the objects are functionally capable, transforming the hypothesis from a wild guess into a demonstrable, physical reality. Yet, this hands-on research also reveals the limits of our certainty. Proving something could have been a battery is not the same as proving it was one. The replicas show us a path that was walkable, but they cannot tell us if anyone from that time ever chose to walk it. They leave us standing at the edge of discovery, holding a working model of ancient potential, and wondering just how far that potential was ever truly explored. The silence of the archaeological record holds its own kind of evidence. For the battery theory to move from intriguing possibility to established fact, we would expect to find the rest of the circuit. Where are the wires, the connectors, the tools that would turn this isolated cell into a working device? This absence is the most substantial argument against the electrical interpretation. In our modern world, a battery without wires is like a key without a lock, a component waiting for a system that may never have existed. Skeptics rightly point out that no spools of ancient wire, no metal clips, no electroplated objects have been discovered in the same context as the jars themselves. It is a gap in the story that cannot be ignored. Yet, this missing link also invites us to think differently about how such a technology might have been applied. Perhaps the connections were not made of durable metal at all, but of perishable materials. Fine threads spun with metallic fibers, or even dampened cords soaked in a saline solution, could have carried a small current. These organic components would have decayed completely over the centuries, leaving behind only the more resilient ceramic and metal parts of the apparatus. Another possibility is that the circuit was completed in the most direct way imaginable, through human contact. An artisan holding a metal stylus connected to the iron rod, while their other hand touched the copper cylinder or the object to be plated, would themselves become the living wire, feeling the current's faint tingle as it passed through their body. This transforms the process from a detached mechanical operation into a physical, almost ritualistic, engagement with the mysterious force, or consider the liquid itself. If 2 or more jars were placed in a shallow basin of the same electrolyte, the conductive solution could have served as the pathway, completing the circuit without any solid connector at all. These alternatives suggest a technology that was not built from standardized components, but was instead an adaptive craft, using whatever was at hand to harness a subtle and poorly understood effect. The lack of conventional evidence, then, might not prove the jars were inert. It might instead point to a form of knowledge so deeply integrated into a specific practice, so reliant on ephemeral materials and hands-on technique, that it left almost no trace beyond its core vessel. We are searching for the skeleton of a system that may have been made of flesh and water. Even the most perfectly designed battery is inert without its vital fluid. The true heart of the Baghdad cell may have been a substance that vanished without a trace, an ancient recipe for power now lost to the air. Identifying what filled these jars is a puzzle of its own, a search for a ghost ingredient in a 2,000-year-old formula. Given the region's climate and culture, several plausible candidates emerge. Vinegar, a common byproduct of wine, would have been readily available, its acetic acid providing a gentle but effective electrolyte. Fermented grape juice or even the tart juice of a local citrus or pomegranate could have served the same purpose. Some theories suggest solutions of brine or water mixed with minerals like alum, substances also used in the dyeing and tanning trades. The choice was not trivial. It would have directly shaped the cell's character. A strong vinegar might produce a higher initial voltage but corrode the iron rod rapidly, creating a short-lived burst of power perfect for a single dramatic ritual. A milder, more stable mineral solution could have provided a lower, steadier current, ideal for the slow, meticulous work of electroplating a delicate piece of jewelry over hours. This technical ambiguity opens a window into how the device might have been used. Was it a tool brought out for special occasions, its jar filled with a fresh, potent brew for a specific task before being emptied and cleaned? Or was it part of a more permanent workshop setup, topped up occasionally like an oil lamp designed for continuous, low-level use? The frustrating truth is that residue analysis on the original jars has been inconclusive. Any organic liquid has long since evaporated or been washed away by the damp earth, leaving behind only the stubborn, silent minerals of the clay and metal. This missing fluid means a crucial chapter of the object's story has literally dried up. We are left studying the empty vessel, forced to imagine the spark that once lived within it. The Electrolyte Enigma reminds us that history is not just made of things that endure, but of processes, of fleeting chemical reactions and momentary connections that leave no fossil behind. It underscores a humbling reality. Sometimes the most important part of a mystery is the part that disappears completely. Fewer than a dozen of these enigmatic jars are known to exist today. Their scarcity is itself a profound clue. Unlike common pottery or coins, which appear by the thousands, these artifacts are rare finds, scattered across museum collections without a complete record of where each one was discovered or what objects lay beside it. The original excavation notes from the 1930s are incomplete, a common reality for archaeology of that era, leaving us with tantalizing fragments of information instead of a clear picture. This lack of provenance, the detailed story of an artifact's origin, is a historian's greatest frustration. It means we cannot say for certain if these jars were found together in a workshop, stored in a temple treasury, or placed in a tomb as grave goods. That lost context could have answered our questions instantly. This dispersion mirrors one of history's most sobering truths: knowledge is astonishingly fragile. Think of the legendary Library of Alexandria, a repository said to have held a vast share of the ancient world's written wisdom. Its loss, whether through a single fire or a slow decline, erased countless works of philosophy, science, and literature, leaving gaps in our understanding that may never be filled. On a smaller, more intimate scale, consider the master craftsperson. Their skill was not held in a book, but in their hands, in the subtle pressure of a tool, the precise timing of a glaze, the secret recipe passed only to a chosen apprentice. If that apprentice fell ill, or if conflict swept through the city, that entire branch of technical expertise could vanish in a single generation, leaving behind only the beautiful, inexplicable objects they created. The knowledge of the Baghdad battery, if it was indeed knowledge, fits this pattern perfectly. It would not have been a public science, but a guarded craft secret, perhaps known only to a specific guild of metalworkers in Ctesiphon or a solitary order of priests in a remote temple. Such niche, specialized understanding exists on a knife's edge. A conquest, a famine, a shift in religious practice, or simply the death of the last person who understood the trick, and the light goes out. The technique disappears from living memory, leaving behind only these odd, silent jars, objects that seem to ask a question we no longer know how to answer. They are not failures of technology, but victims of time, physical whispers of a conversation that was cut off centuries ago, leaving us to piece together the echoes. A curious tingle on a wet fingertip could have sparked the entire mystery. We often envision ancient discovery as a deliberate, almost scholarly pursuit, but history's greatest leaps often begin with a simple accident. Picture an artisan's workshop not as a sterile laboratory, but as a space of constant, messy interaction with the physical world. Here, metals were cleaned in acidic vinegar baths, dyes were brewed from fermented plants, and bitumen was heated for waterproofing. In this environment of hands-on experimentation, serendipity was a silent partner. A copper amulet left too long in a jar of citrus juice beside an iron nail might have developed a strange, faint shimmer. A craftsperson reaching into a vinegar pot to retrieve a tool could have felt a peculiar, buzzing vibration where two different metals met the liquid. This sensation, utterly inexplicable by the knowledge of the time, would not have been dismissed. It would have been noted, a novel quirk of the materials they knew so intimately. The journey from that accidental observation to the crafted Baghdad battery is a story of practical genius. An artisan, driven by curiosity, would have begun to play with the variables. They might have noticed the effect was stronger with certain metals or with a particular brew. They would have sought to control it to make the strange tingle happen reliably. The clay jar became a stable container. The asphalt plug served to hold the metals in perfect, insulated alignment. What began as a chance event was slowly shaped through trial and error into a reproducible apparatus. This is not the story of a theoretical physicist understanding electron flow, but of a master craftsperson perfecting a technique. They did not need to know why it worked, only that it worked, and how to make it work again for their purpose, whether that was to deposit a layer of gold or to create a sacred sensation. This perspective reframes the artifact profoundly. It becomes less a relic of lost high science and more a testament to the power of empirical tinkering. It represents innovation born from the marriage of daily necessity and open-ended curiosity. The battery, in this light, is a monument to the countless unnamed experimenters who, through keen observation and a willingness to explore the unexpected, pulled practical wonders from the chaos of the material world. Their legacy is a reminder that the spark of discovery often flies not from the pages of a grand theory, but from the humble, hands-on engagement with the stuff of life itself. The artifacts themselves may hold the answer, shimmering quietly in museum cases across the world. Scattered throughout Mesopotamian collections are small, exquisite objects, delicate statues and intricate pieces of jewelry, plated with a layer of gold so astonishingly thin and perfectly even that it has long puzzled historians. Traditional methods of the time, like mercury amalgam gilding, involve applying a paste of gold and mercury to an object and then heating it to vaporize the mercury, leaving the gold behind. This technique can produce a thick, rich coating, but it is also prone to slight unevenness and can leave a microscopic texture. Some of the surviving plated items, however, display a gold layer of almost impossible consistency, a whisper-thin film that clings to every contour with a uniformity that feels more like a chemical bond than a physical application. This subtle discrepancy in craftsmanship is where the battery theory finds a potential purpose. If an ancient artisan had access to even a weak electrical current, the process of electroplating would naturally produce exactly this kind of result. The current pulls individual gold particles from a solution and deposits them molecule by molecule onto the target surface, creating a bond that is not just adhesive but metallurgical, and a finish that is flawlessly even because it grows atomically from the object outward. These gilded treasures, then, are not merely beautiful relics, they are potential physical evidence. They could be the silent, polished products of the very technology we are trying to understand. A copper pendant connected to a clay jar filled with vinegar and a gold solution would slowly gather a radiant skin of pure gold, a transformation that must have seemed nothing short of magical. This creates a powerful, if circumstantial, link. On one side, we have the mysterious jars, proven by modern experiment to be capable of generating a current suitable for such a task. On the other, we have these masterfully plated objects, which display the exact characteristics that such a current would produce. Together, they form a complete and elegant loop of cause and effect, providing a clear and practical motive for why someone would bother to invent such a device in the first place. It moves the mystery from a question of could they to a question of did they, and points to the answer being written not in text, but in the very metal of their most prized possessions. But the evidence is not confined to silent objects alone. Words, passed down through fragile manuscripts, whisper their own supporting testimony. While no ancient text provides a clear step-by-step guide for constructing an electrical cell, several writings from the region contain passages that glow with new meaning when read through the lens of the Baghdad battery. These are not explicit descriptions, but rather cryptic recipes and enigmatic accounts that hint at a deeper, practical knowledge of chemical interactions. For example, consider the vast body of alchemical literature that flourished during the Islamic Golden Age, a period that drew heavily upon the earlier scientific traditions of the Sasanian Empire. These texts, often concerned with the transformation of metals, describe processes involving specific combinations of metals, acids, and sealed vessels. One might discuss the treatment of copper with a sharp vinegar in a sealed container to produce a change in its color or luster. To a modern reader familiar with basic electrochemistry, this sounds less like mystical transmutation and more like a careful, if not fully understood, experimental procedure that could easily generate a small electrical potential as a side effect. The alchemists seeking to turn base metals into gold may have been documenting the very reactions that power the clay jars, interpreting the results through their own philosophical framework. Other ancient accounts speak of treasures that shone with a cool, steady light, yet were not made of any recognizable precious metal. Descriptions of temple artifacts that gleamed without flame or held a captive radiance have often been dismissed as poetic metaphor. Yet, if a priestly class possessed even a handful of these cells, they could have used them to power a simple, primitive form of illumination. A thin wire of iron, connected between the terminals and heated by the electrical current until it glowed a dull red, would have produced a faint, eerie light in a dark chamber. This would not be a practical lamp, but as a ritual object, a demonstration of controlled celestial fire. Its impact would have been profound. These literary clues are undeniably ambiguous, a tapestry woven with threads of chemistry, spirituality, and craftsmanship. They can be interpreted in multiple ways, and no single passage is definitive proof. However, their collective weight is significant. They paint a portrait of a long, continuous tradition of hands-on experimentation with the hidden properties of materials. Within that tradition, the physical Baghdad batteries cease to be bizarre outliers. Instead, they become the solid, tangible anchor points, the real-world artifacts that give form to the vague processes and wondrous effects described in the texts. They are the missing piece that makes the cryptic words suddenly resonate with practical possibility, suggesting that the line between ancient alchemy and early science was far thinner and far more charged with potential than we ever realized. A single, fragile thread connects discovery to oblivion. How could such a tangible concept, once held in the hands of a craftsperson, simply dissolve from the collective memory of a civilization? This question pushes us beyond the artifact itself, into the deeper rhythms of how human understanding breathes and fades. One compelling theory views knowledge not as a steadily rising tide, but as a flickering candle passed between generations in a vast, drafty hall. Entire libraries of technique can be extinguished by a single gust of history, a conquest that scatters a guild, a famine that starves out apprentices, or a shift in religious belief that renders a practice forbidden. Specialized skills like the precise control of an electrochemical reaction were often the closely guarded property of a small group, a priestly order, or a family of metalworkers. This knowledge was transmitted through demonstration and whispered secret, never written down for fear of losing its power or its market value. When that lineage was broken, the light went out, leaving behind only the puzzling tools. The utility of the battery itself may have been its own limitation. In a world without a concept of electrical networks, what was the purpose of a single volt? It could gild a small pendant or create a temple wonder, but it could not light a city, power a mill, or revolutionize transportation. Its applications were niche, beautiful, and perhaps ultimately seen as a clever trick rather than a transformative force. Without a broader infrastructure to support it, without a pressing societal need to drive its refinement, it remained a technological cul-de-sac, an intriguing branch on the tree of innovation that simply stopped growing. This pattern echoes in other lost marvels, the formula for Roman concrete, which created structures that have endured for millennia, vanished for centuries. The precise tempering process for Damascus steel blades was lost to time. These were not failures of engineering, but casualties of context. A technology thrives only when it is woven into the fabric of daily life, trade, and necessity. When that fabric unravels, even the most brilliant threads can slip away, leaving us to wonder at the intricate patterns they once formed. This enduring puzzle has long since escaped the dusty shelves of academia. The Baghdad battery has sparked a vibrant second life in the realm of popular imagination, becoming a beloved icon of historical mystery. It features prominently in television documentaries exploring ancient anomalies, serves as a plot device in best-selling novels, and even appears as a collectible artifact in major video game franchises, often presented as definitive proof of out-of-place technology. In these stories, it is rarely just a clay jar. It transforms into a key, a literal and metaphorical power source for narratives about lost advanced civilizations. This cultural footprint is immense, revealing something profound about our relationship with the past. The artifact resonates because it actively challenges the comforting, linear narrative of human progress, that steady climb from primitive to advanced. It whispers a more thrilling and unsettling possibility, that history might not be a straight road, but a landscape dotted with isolated peaks of achievement, peaks that were later shrouded in fog. This idea fuels an entire genre of speculative fiction and alternative history, inspiring tales of forgotten golden ages where science and myth were intertwined. This public fascination is not a distraction from serious study. It is a vital part of the conversation. It demonstrates a deep public desire to question the official record, to wonder what might be missing from the textbooks. These creative interpretations, while often fantastical, serve a crucial purpose. They keep the question alive in the collective mind. They remind mainstream archaeology that its work is never truly finished, that it must continually engage with these captivating public ideas, not to dismiss them, but to rigorously test them. This dynamic tension between established science and public wonder is healthy. It pushes researchers to refine their methods, to seek clearer evidence, and to communicate their findings in compelling ways. The journey of the Baghdad battery, from an Iraqi dig site to a global symbol of mystery, proves that some discoveries are more than just objects. They are catalysts for endless curiosity. The voltage reading on the modern researcher's multimeter tells a clear but quiet story. Replicated cells consistently produce a modest output, often hovering between 0.5 volt and 1.5 volts. To our modern sensibilities, accustomed to the instant power of a smartphone or the bright glare of an LED, this seems almost laughably insignificant. A single A battery delivers 1.5 volts, a seemingly trivial amount, yet it powers a remote control for months. The ancient cell's output, while measurable, presents a genuine puzzle of scale. What could such a faint whisper of energy actually accomplish? Skeptics frame this as the central flaw in the battery theory, arguing that such low power simply couldn't drive any meaningful ancient technology. It seems insufficient for serious electroplating, too weak for any form of practical lighting, leaving it as little more than a curious laboratory trick. This is a valid and necessary critique. It forces us to move beyond the simple, thrilling proof of concept, the fact that it can generate electricity, and confront the more complex question of practical application. If the effect was so subtle, why would anyone go through the deliberate trouble of crafting these specific jars? The answer may lie not in our definition of utility, but in theirs. We judge the output through the lens of machinery and efficiency. An ancient priest or artisan, however, lived in a world where subtlety held immense power. A gentle, consistent tingle on the skin, a sensation that could be felt but not seen, might have been far more valuable in a temple setting than a blinding spark. In a ritual context, the goal isn't to illuminate a room, but to illuminate belief. That faint, mysterious vibration transferred from a metal idol to a worshipper's hand wouldn't need to be strong. It only needed to be undeniable and inexplicable. Its utility was psychological and spiritual, measured in awe and authority, not in watts. Furthermore, our modern replications, while scientifically sound, operate under a set of idealized, controlled conditions. We use fresh, pure acids and meticulously cleaned metals to achieve a consistent result. The ancient reality was likely far messier. The electrolyte might have been a batch of vinegar of variable strength. The iron rod might have been corroded. The asphalt seal might have had tiny cracks. This doesn't invalidate the device, it simply frames it as a product of its environment, a technology that worked well enough for a specific, accepted purpose within the cultural tolerance of the time. Its success wasn't judged by a digital readout, but by whether the gold stuck to the pendant, or whether the initiate felt the divine presence. This critical scrutiny doesn't dismantle the mystery, it deepens it. True historical detective work isn't about proving a single, spectacular answer. It's about weighing the evidence, understanding the context, and sitting with the uncomfortable, fascinating possibility that our ancestors might have measured the value of a spark by a standard we have long forgotten. The true nature of these jars cannot be unlocked by any single key. Solving a mystery this profound demands a convergence of minds, a meeting point where the careful dust of archaeology brushes against the precise calculations of physics and the reactive truths of chemistry. This is no longer a question for the solitary historian in a library. It is a scientific puzzle that requires a holistic, interdisciplinary attack. Each field brings its own essential lens to the investigation, and only by combining their visions can we hope to see the complete picture. Archaeologists provide the foundational story, the context. Their work asks the crucial human questions: where was this object found? What else was nearby? Who might have used it? And for what purpose in their daily or sacred lives? They are the keepers of provenance, the ones who can tell us if a jar was discovered in a metalworker's quarter or a temple storeroom, a distinction that would radically reshape its possible identity. Yet, archaeology alone hits a wall when faced with the object's function. This is where the chemist steps in. Using tools like advanced spectroscopy, a chemist can analyze the interior surface of the clay for microscopic residues, hunting for the ghostly fingerprints of ancient electrolytes, trace elements of vinegar, wine, or minerals that evaporated 2,000 years ago. They study the unique corrosion patterns on the iron rod, which can reveal if it was degraded by a specific acidic solution over time, rather than by random soil conditions. The chemist's work transforms the jar from an artifact into a chemical reaction waiting to be understood. Then, the physicist takes this data and brings it to life. They build precise digital and physical models to calculate the electrical output, not just of one cell, but of multiple cells connected in series or parallel. They experiment with different configurations to see what level of voltage and current could be realistically achieved, and what tangible effects that power could produce, from the thickness of an electroplated layer to the temperature of a glowing wire. This collaborative model is the future of investigating historical anomalies. It treats the past not as a static story to be read, but as a dynamic system to be reverse engineered. For the Baghdad battery, this means materials scientists might study how the asphalt sealant degrades, confirming its effectiveness as an ancient insulator. Engineers could replicate the exact porosity of the local clay to understand how an electrolyte would wick and interact. This interdisciplinary approach does something beautiful. It transcends the traditional boundaries of academia, forcing experts to speak a common language in pursuit of a shared truth. The clay jar ceases to be just an archaeological find or a chemical curiosity. It becomes a nexus point for human ingenuity, a single object through which we can explore the interconnected worlds of craft, science, and culture. It reminds us that the deepest mysteries of our past are not locked away in one discipline's vault, but are waiting in the open space where all fields of inquiry finally meet. Perhaps the most profound impact of these clay jars lies not in their voltage, but in the voltage they send through our own understanding of history. We are taught a story of linear ascent, a neat timeline where humanity marches steadily upward from the Stone Age to the Silicon Age, each generation building directly upon the last. This narrative is comforting and clear, but artifacts like the Baghdad battery introduce static into the signal. They suggest a different model altogether, one not of a smooth incline, but of a rugged terrain with isolated peaks and deep valleys. In this landscape, knowledge does not always accumulate. It can flourish in one sheltered valley, guarded by a single guild or temple, only to be completely forgotten when that community disperses or falls silent. The idea that electricity could be understood, even in a practical, hands-on way 2,000 years ago, directly challenges the assumption that such a discovery was an inevitable product of the 18th or 19th century. It was not an inevitability waiting for Volta or Faraday. It was a possibility that flickered into existence because of a specific confluence of curiosity, materials, and need in ancient Mesopotamia. This reshapes how we see the people of the past. They cease to be primitive figures merely waiting for the dawn of modern science to illuminate their world. Instead, they emerge as our intellectual equals, as full and capable experimenters engaging with their environment with the same ingenuity we pride ourselves on today. Their experiments were framed by different questions, guided by different philosophies, and aimed at different ends, perhaps spiritual or artistic rather than industrial, but the cognitive spark was the same. We begin to see that our map of history is not the territory. Vast stretches of their intellectual landscape, their trials, their failures, and their quiet triumphs remain unmapped by our scholarship. The Baghdad battery is a single, tantalizing landmark on that lost map, a cairn left behind that tells us the journey was far more complex and the travelers far more resourceful than our simple story of progress has ever allowed. A definitive answer still lies buried, waiting for the right spade to strike earth. The debate over these clay jars may ultimately be settled not in a laboratory, but in the field, by the next great archaeological discovery in the lands of ancient Mesopotamia. Imagine the scene: a team carefully excavating a structure identified as a metalworker's studio or a temple storeroom. Their trowels reveal not one solitary jar, but a dozen, arranged in a deliberate row. Beside them, nestled in the dust, are thin strips of copper or bundles of wire, perhaps even a small, corroded metal object showing clear signs of electroplating. Such a find would be transformative, a time capsule preserving the complete apparatus. It would show us the system in its intended state, proving beyond reasonable doubt that these cells were connected, that they were meant to work together to amplify their modest power for a specific, practical task. This is the smoking gun scenario that historians dream of, a context so clear it closes the case. Alternatively, the proof might come from a different kind of discovery altogether. A carved stone relief or a painted fresco, uncovered in a palace or temple, could depict the jars in use. We might see a figure, perhaps a priest or artisan, holding wires between the terminals, or observe a statue being treated with connected vessels at its base. Visual evidence of this nature would provide a direct window into the practice, showing us the human element, the ritual or craft that gave these objects meaning. Even more compelling would be a text, a cuneiform tablet or a later parchment, that moves beyond cryptic alchemical recipes to offer explicit instructions. A passage detailing the assembly of a copper cylinder, an iron rod, and a plug of bitumen, followed by a directive to fill it with vinegar to draw forth the hidden shine or bestow the touch of the divine, would instantly rewrite the chapter. While no such text has been found, the vast majority of writings from these empires are lost to us, making its existence a tantalizing possibility. Our tools for interrogation are also advancing. Future archaeologists will not rely solely on the naked eye. Sophisticated, non-destructive testing techniques like advanced chemical imaging and three-dimensional X-ray analysis may one day peer into the very fabric of the existing jars without damaging them. These methods could detect vanishingly faint residues of electrolytes absorbed deep into the clay's pores, or map the precise crystalline structure of corrosion on the iron rod, distinguishing between chemical reactions from intended use and those from centuries in the soil. Each artifact in a museum case today is not a closed book, but a document waiting for a future technology to decipher its faded ink. This forward-looking perspective is crucial, for it reminds us that history is not a static puzzle we have already solved. The story of human ingenuity is an ongoing excavation. Every new dig in the regions once ruled by the Parthians and Sasanians carries this potential, the chance to uncover a find that either confirms this ancient spark or finally, definitively, explains it away as something more mundane. The clay jars of Baghdad stand as a powerful symbol of this uncertainty. They represent all the questions we have not yet answered, all the silent workshops and lost libraries that still hold their secrets tight. They teach us that the past is not a country we have fully mapped, but a landscape where, at any moment, the ground might shift and reveal a truth far more wondrous than we ever assumed. The mystery endures, and in that endurance lies its greatest gift, the perpetual invitation to keep looking, to keep wondering, and to remain humble before the vast, untold ingenuity of those who came before us. The true power of this ancient object may not be measured in volts, but in the questions it forces us to ask. Beyond the historical debate, the Baghdad battery serves as a masterclass in critical thinking, a tangible puzzle that teaches us how to navigate uncertainty. Here we have a clear, physical problem with multiple, competing explanations, each supported by a different reading of the evidence. This is not a dry academic exercise, it is the very essence of how we uncover truth. In a classroom or a curious mind, the artifact becomes a tool. Students can examine the same primary evidence we have explored, the jar, the metals, the corrosion. They are presented with two strong, evidence-based hypotheses, the electroplating tool and the sacred scroll case. Their task is not to guess the right answer, but to learn how to build a case. They must weigh the strengths and weaknesses of each argument. Does the absence of wires definitively disprove the electrical theory, or could the connections have been perishable? Does the presence of similar scroll containers in other cultures make the storage theory more likely, or does the specific combination of materials suggest a more specialized purpose? This process reveals a fundamental truth about history. It is not a collection of fixed facts, but a continuous conversation shaped by interpretation. The artifact demonstrates the core principles of scientific methodology in action. It shows why skepticism is not cynicism, but a necessary filter. It highlights the indispensable role of reproducible experimentation, as seen when modern researchers built replicas to test the voltage output. Most importantly, it serves as a vivid warning against confirmation bias, the human tendency to favor information that supports what we already believe. Someone convinced of ancient advanced technology might overlook the simpler scroll case explanation, while a staunch traditionalist might dismiss the electroplating evidence as mere coincidence. The lesson is to hold all possibilities lightly, to let the evidence guide the way, even when it leads to uncomfortable or surprising places. In this light, the clay jar's greatest legacy is not rewriting history, but inspiring how we think about it. It encourages a mindset of healthy inquiry, teaching future generations to dissect the narratives we accept about our shared past. It reminds us that the most valuable skill we can cultivate is not memorizing answers, but learning how to ask better, sharper questions. This humble vessel, silent for 2 millennia, becomes a voice for intellectual independence, proving that some mysteries are most valuable not when they are solved, but when they teach us how to wonder. The weight of the evidence rests in the balance, with compelling arguments on both sides of the ancient clay. To truly grasp why this mystery endures, we must listen to each case with equal respect. The argument for the Baghdad battery as a genuine electrical device is built on a sturdy tripod of evidence. First, the design itself is functionally precise. The deliberate pairing of two dissimilar metals, copper and iron, held apart by an effective insulator, mirrors the basic blueprint of a galvanic cell. This is not a random assortment of scrap, it is a specific configuration that produces a specific effect. Second, modern replication proves that effect is real. Fill a faithful copy with vinegar, and it generates a measurable current, a tangible spark of possibility that an ancient artisan could have felt and harnessed. Third, the historical context supports it. This was a civilization of master metalworkers, skilled in complex gilding, and constantly experimenting with acids and minerals in their craft. The discovery of electroplating through such tinkering is not a leap of faith, but a plausible step in a long tradition of hands-on material science. Together, these points form a coherent and seductive narrative of forgotten ingenuity. Yet the case against this interpretation is equally robust, grounded in the sobering discipline of archaeological proof. Its foundation is a profound absence. Where are the wires, the connectors, the electroplated objects found directly alongside these jars? If this was a widespread technology, we would expect to find the rest of the circuit. The lack of such associated artifacts is a silence that speaks volumes. Furthermore, a simpler, well-attested alternative exists: the scroll storage hypothesis. Sacred texts were precious, and sealing them in a copper cylinder within a clay jar, using an iron rod as a convenient handle, is a perfectly logical use for such objects, one that requires no invocation of lost science. This leads to the guiding principle of Occam's razor, which suggests that among competing hypotheses, the one with the fewest assumptions is often correct. In this light, a scroll case is a straightforward explanation, while an ancient electrical cell requires a cascade of additional assumptions about lost knowledge, undiscovered applications, and a complete absence of corroborating evidence. This perspective is not a dismissal of wonder, but an application of rigorous historical method. So where does this leave us? It places the Baghdad battery in a fascinating and permanent state of limbo, a category all its own. It is more than a mere curiosity, yet less than a confirmed technology. It is an anomaly that refuses to be neatly filed away, precisely because the evidence for both sides is compelling, yet crucially incomplete. We cannot prove it was a battery, but we can no longer dismiss the possibility as pure fantasy. This unresolved tension is the artifact's true legacy. It teaches us that history is not a solved equation, but an ongoing dialogue between what we find, what we can prove, and what we are brave enough to imagine. The clay jar sits at the center of this dialogue, a silent witness to a conversation that has spanned nearly a century, inviting each new generation to examine the evidence and draw their own line between the possible and the proven. These clay jars of Baghdad remain one of history's most provocative whispers, a silent challenge from the past that asks us to reconsider the ingenuity of ancient civilizations. They force us to confront a humbling truth. Our timeline of discovery is not a simple upward line, but a complex tapestry woven with threads we have yet to find. Whether these objects were batteries for a forgotten craft, sacred instruments for a temple rite, or simply elegant containers for precious texts, their true power lies in what they represent. They are undeniable symbols of the human capacity for innovation, for looking at a piece of copper, an iron rod, and a clay pot, and seeing not just a vessel but a possibility. They highlight the enduring gaps in our historical understanding, those quiet spaces between the artifacts where entire chapters of human thought may have been written and then lost. This mystery ultimately teaches us a profound humility. It reminds us that the people of the past were not primitive figures awaiting our enlightenment. They were our intellectual equals, full of the same cleverness and burning curiosity that drives us today. They experimented, they tinkered, and they sought to harness the mysteries of their world with the tools they had. Let this story inspire you to look at all of history with questioning eyes, to wonder not just what we know, but what magnificent fragments of knowledge might still be buried, waiting for their spark to be felt again. If you found this journey into ancient possibility fascinating, subscribe for more deep dives into history's greatest puzzles. We would love to hear your own theories about the Baghdad battery in the comments below. What do you believe was the true purpose of these enigmatic jars?